So in this first example, you've been told, show clearly that log 36 to base a plus a half log 256 to base a minus 2 log 48 to base a is equals to negative log 4 to base a, isn't it? So from here, the laws of logarithms, you just apply the laws of logarithms. If you have the same base, then you can use, if you have the same base with addition or subtraction sign, then you can use this law, isn't it? If you have log xy, that is the same as log x plus log y, isn't it? The base must be the same all through, meaning if this is base a, those other ones must be base a, isn't it? You see that? And if you have log x over y, that is the same as log x minus log y, isn't it? So if this is base a, everything must be the same base, isn't it? So it means here, anywhere you see subtraction, it goes back to division, isn't it? Anywhere you see addition, it goes back to multiplication. So if you come back to our problem here, you'll be given, if you come back to our problem here, we have log base a, isn't it? We use what is in the left-hand side of the equation until we get what is on the right-hand side of the equation. So the left-hand side of the equation, we have log 36 to base a plus a half log 256 to base a. So the coefficient is the power of the number inside the log, isn't it? So it means this a half is the power of 256, isn't it? Then you move on, minus log 48 to base a, meaning this 2 is the power of 48. The coefficient of the log is the power of the number inside the log, isn't it? Are we together? So this one is equals to what? Now we don't have the coefficients. That is the first step, to get rid of the coefficients, isn't it? After getting rid of the coefficients, it means what is on the right-hand side of the equation is what we come back to the left, isn't it? Meaning where there's addition, if you remove log to base a outside, the way it is outside here, if you remove it outside, meaning we'll have 36, where there is addition goes back to multiplication the way it was, isn't it? So it goes back to 36 times 256 raised to power half, isn't it? Then where there is subtraction goes back to division, isn't it? Where there is subtraction, you come back to division, where it's supposed to be if you remove log a outside, isn't it? So minus 48 raised to power 2. So if you work out this, what do you get? 36 times 256 raised to power half, divide by 48 squared, what do you have? 256 raised to power half is the square root of 256, isn't it? Which is 16, isn't it? So 256 raised to power half is 16. So it is like you have 36 times 16 divided by 48 squared, which is 36 times 16 divided by 48 squared. What do we have there? 36 times 16 divided by 40. This is times multiplication, but we normally use the dot. 0 in fraction, 1 over 4. So it is 1 over 4, isn't it? So if you use the laws of indices, what is 1 over 4? 4 raised to negative 1, isn't it? So 1 over 4 means log 2 base a, then 1 over 4 means 4 raised to negative 1. Negative 1 means reciprocal, isn't it? Are we together? Because this 1 over 4, you can as well say 1 over 4 is 4 raised to power 0 over 4 raised to power 1, because any number raised to power 0 is that, isn't it? So laws of indices, same base with division sign you subtract, isn't it? So that is 4 raised to negative, isn't it? So you found that. Then in laws of logarithms, which law of logarithm again do you know? You know that when you have maybe log x to power a, then the power is expressed as the coefficient of the log, isn't it? So this power negative 1 becomes the power negative 1 becomes the coefficient, isn't it? Are we together? So you bring this negative 1 here, you have negative log 4 to base a, and you've actually showed that this is equal to that. Meaning you start with the left hand side until you get what is on the right hand side of the equation. Are we together there? So you have, this is negative 1 log 4 to base 8. The negative 1 power becomes the coefficient. Are we together? Good.